for being so awesome. All of first, I have two presentations by Mr. Cappucci, so I'm going to turn it over to him, and we're going to, we'll start our coffee break around 10:15.
I promise you'll get your coffee. Now, Dan mentioned that it was a 16-year-old who created the fake Facebook lizard. I promise I had nothing to do with it. Alright, let me just turn the volume down because I have some sound effects. Alright, so for starters, thank you guys all for giving me this opportunity to present today. It's been great getting a chance to know you guys over the past couple years at the conferences, and I really appreciate all of you welcoming me back. It's been a great experience. So I'm doing a presentation on cookie-cutter weather warnings. Now, presenting here has always been on my bucket list, so fortunately I think I can cross this off my bucket list. The next thing on my bucket list, I just checked this morning, happens to be doing the weather before I graduate high school. So I have the lapel microphone, I have the clicker, all I need. So as you guys know, I'm from Cape Cod, and unfortunately the weather on Cape Cod has been absolutely awful lately. It's been cold, we haven't had any summer, and it's been so boring. But I checked out the forecast for Reno, Nevada, and I figured that there are some places in the United States that have slightly more boring weather than we do on Cape Cod. So in order to keep it a little bit lively, I decided to, rather than just lecture a little bit, I wanted to show you the problem we're facing with the weather warnings. This is a real weather warning issued back on February 14th from the National Weather Service in Medford, Oregon. I want you to take a look. Copied and pasted directly from the text. So you can see there are 7 different products issued for the same reason. Small craft.
Arrow of your screen.
Oh, sure, thank you. Small craft advisory. 2 small craft advisories, as a matter of fact. Hazardous seas warning, gale warning, storm warning, hazardous seas watch, and gale watch in effect. I don't know how there can be a hazardous seas watch and warning in effect at the same time, but somehow there is. So we're going to play a little bit of a memory game, because the average person has only between 15 and 25 seconds to get all the information they need from a weather warning. After that, they'll either stop listening or just lose interest, and they won't be able to absorb all that information. So you guys are going to have about 10 seconds to try to soak up as much of this information as you can, and then there'll be a 3-question quiz. Ready? All right, first question. Weather Service in Medford, Oregon for this region. Does anyone?
Storm warning.
Storm warning? We'll see. Yep, storm warning. Nice job. All right, question 2. What were the 2 types of small craft advisories issued? Anyone?
Small craft advisory.
Yeah, for hazardous seas and for winds. And third question, for what times was a storm warning in effect?
Your future. Yep.
Saturday
and then Saturday.
So you guys get the idea. If we have warnings issued like this, if we have so many warnings issued, or just any type of warning, because of the technicalities, the public's not going to get it. So that's my message with this presentation. You guys did great, by the way. So that brings me to the essential question. If no 2 events are alike, if every weather event is unique, then why are we still issuing warnings in the same roundabout, cookie-cutter manner? I think that's the big question for this presentation. So to take a look, we're going to investigate a little bit about some of the events excluded from traditional weather warnings, things where there aren't products to cover them. We're going to talk about how sometimes it's necessary to break the rules in issuing severe weather warnings. I have a couple different case studies from the tornado warnings issued during Hurricane Katrina, and sometimes it's necessary to go above and beyond. As Brian Norcross explained earlier, a typical hurricane or typhoon warning for high on just wasn't enough, and sometimes you need to go above and beyond. And we'll evaluate how sometimes failures and technicalities can get in the way of successful and effective warnings, particularly in the cases of Joplin and Sandy. So that brings me to the first event. This was back on February 11, 2003, out of the National Weather Service in Lincoln, Illinois. And here's the base reflectivity during that. You can see reflectivities right around 45 to 50 decibels. And it's not that impressive if this is a rain event, but when we consider the fact that this is all snow, it ends up being really impressive. When we take a look at the base velocities as well, and you can see velocities anywhere between 45, 50, even sometimes near hurricane force. So very impressive event at the very least. There was a presence of scattered cloud to ground lightning, some of which was positive lightning, being known to be 3 to 100 times more powerful than traditional lightning. And this is an area with a history of strong thundersnow. In fact, back on the 25th of January 1990, lightning struck a light pole in Crystal Lake, Illinois, and a charge traveled through the ground and injured seriously 9 people who were shoveling or pushing stranded motorists. And there's a history of strong to damaging winds with this line, oftentimes reaching hurricane force. In fact, I think it actually knocked the train off its tracks. The train was carrying many batteries, and snowfall rates were 1 to 3 inches an hour. So to keep it lively, we're going to play a little game of Family Feud here. All right, we even have the music going. So what would you guys issue? All right, if you had an event like this, what kind of things would you issue? Anyone?
Blizzard warning.
A blizzard warning. Well, for starters, a winter storm warning wouldn't work because you have to have 6 or more inches in a 12-hour period or 8 or more in a 24-hour period. So Mr. Satterfield said a blizzard warning. That would make sense. But unfortunately, due to the technicalities, they were limited and they couldn't issue that because a blizzard warning is issued when sustained winds or frequent gusts of 35 miles an hour are expected for at least 3 hours along with the falling and drifting of snow. And because this line was moving so quickly, in fact, near 65 miles an hour, couldn't issue that. What about a high wind warning? Because winds are the primary threat, even neglecting the visibilities. Couldn't do that because that requires sustained at 40 for at least an hour, or 58 at any time, and unfortunately we did not have it for an hour. But there's one product left. They ended up being a little bit creative in breaking the rules, which is what my message is. Sometimes you have to break the rules of traditional weather warning. And they issued a severe thunderstorm warning. Now I have a copy of that text here. That severe thunderstorm warning, all right, here we go. That was late in the afternoon, 6:02 p.m. They issued 5 of them, and they mentioned the possibility of heavy snow coupled with damaging winds in excess of 60 miles an hour. And I spoke to Lyle Baker III. He's the Science and Operations Officer at the National Weather Service there. And he said, due to the rapid motion, which was near 65 miles an hour, all the downdrafts associated with the storm brought severe winds to the surface, oftentimes exceeding hurricane force. And they think that those warnings issued were highly effective. And they were issued because of the presence of lightning coupled with the 58-mile-an-hour winds. So that brings us to our second topic. We've discussed lightning already and how that qualified for the issuance of the severe thunderstorm warning there. But what about convective fine lines? These are my least favorite. I absolutely hate them. They look, they behave, and they do everything that thunderstorms do, minus the thunder. This is an event back on September 18th, I think, 18th into the 19th in 2012. And this was a major storm system stretching all the way down from Maine through the Carolinas, and they didn't even produce lightning until they reached south of, I think, the Delmarva Peninsula. But it looks like a thunderstorm. You can see right there, there's a little bit of pink in the line. Here we go, right there. They produce numerous tornadoes, and that's what we normally have with convective fire lines. There's little to no lightning produced, but it produces short-lived damaging winds, occasional tornadoes from the kinks in the line that you get, as well as, extremely heavy rain. And that's what we saw on September 18th, 2012. We had a low-top QLCS all the way down from the Carolinas up through Maine. And they issued numerous severe thunderstorm watches for this, but they mentioned the possibility of the heights only reaching 25,000 feet, which is not really enough for charge separation. But with that, the fact that there was no lightning, we had over 150 reports of severe weather, including 2 reports of tornadoes in the Carolina region, and the winds were the main story. So they issued that severe thunderstorm watch, even though there really were no severe thunderstorms because there was going to come back to fire lines, and there was no lightning produced. Now, I want to show you this. This is how several local National Weather Service offices handled the warnings. And out of New York, they just said severe thunderstorms with the history of wind damage. And I think that's interesting, because what is a severe thunderstorm? It produces thunder, it produces lightning, and a lot of the time, people are going to wait for the thunder and lightning before they seek shelter, which is why I think that was extremely dangerous. Taunton was a little bit better. They said a line of showers and thunderstorms. I personally don't think that's much better. Mount Holly, New Jersey, I think, did the best job out of anybody. They even have a pre-templated statement that they use during convective fire line events. It simply said, it may contain little or no lightning. Do not wait to hear thunder before seeking shelter. And National Weather Service out of Baltimore and DC did the same thing. So we see sometimes they had to break the rules and manipulating the text manually, not just saying severe thunderstorm warning, let's cut it. They manipulated the text manually and included that additional statement, which really, I think, probably saved lives as well as property. That brings me to my third topic, lightning. Lightning's one of nature's #1 killers, as we saw before. This was an event we had back the day before the broadcast conference last year in Nashville. This was over Cape Cod. It was June 24, 2013, and I was right there at the time. It was an incredible lightning producer. I'd never seen anything like it. We had lightning rates in excess of 60, even 70 flashes per minute. Never seen anything like that on Cape Cod. But the interesting fact, there wasn't even a severe thunderstorm warning issued, despite the fact it produced nickel-sized hail and damaging winds around 50 miles an hour. It's fairly gusty, not necessarily damaging. But coupled with the lightning, I figured they would have issued a severe thunderstorm warning. And let's take a look at the statistics, because lightning as it is now, we've seen is not considered when issuing severe thunderstorm warnings. Hail and damaging winds are. In order to have a severe thunderstorm, you have to have 57.5-mile-an-hour winds or greater, along with quarter-size or larger hail, and possibly even a tornado or mesocyclonic waterspout. We didn't see that. Now, they issued severe thunderstorm warnings for hail, but in the past 10 years, according to the National Weather Service, there have only been 3 hail fatalities. Meanwhile, 401 lightning fatalities, that's nearly the same amount as that of severe wind and hail combined. So my question is, why is lightning not considered when issuing severe thunderstorm warnings? I definitely think it should be a factor. It might not necessarily need to be a criterion, but I definitely think it needs to be a factor. Because with this storm, there were 26 injured at a Boy Scout camp prior to the issuance of any statements even. That was in Belmont, New Hampshire, as I rode down the coast. And I got some pretty interesting pictures. I was at the beach at the time, as I told you guys, and I was experimenting with the camera. And I happened to use 80-second exposures. I didn't know what an exposure was at the time. But I captured these pictures, and they ended up coming out really neat. So we saw lightning. We figured that needs to be added. Now, this is the transition time into not only necessarily breaking the rules of traditional weather warnings, but sometimes going above and beyond, as Barney Norcross said earlier. Sometimes traditional warnings aren't enough. So Hurricane Katrina, we know, was an incredible event. There's some reflectivity there. And take a look at the velocity, and you can see winds in excess of 120, 130 miles an hour, sometimes sustained. Here's that still of the eye wall. And I want you to compare this to a damaging tornado we had in Massachusetts back on August 10th, 2012. They look very similar, their apparitions on radar. So I just wanted to show you that, because the National Weather Service and New Orleans actually issued 13, I believe, tornado warnings for extreme winds over 100 miles an hour. Because they knew, with the hurricane warning already in effect, combined with the fact that there was a high wind warning, those two just didn't do it justice. I mean, a hurricane warning is for 74+ mile-an-hour winds. And despite the fact that this was a heavily evacuated area, they needed to do something to get those people to seek a place of last refuge, with winds of 100 to 120 miles an hour sustained that would last at least an hour and a half or 2. So that's why they broke the rules again and issued 7 tornado warnings for extreme winds they wrote with gusts between 100 and 120 miles an hour. That actually led to the creation of a new product. I don't know if you guys have heard this yet, but this was created about 4 or 5 years ago in the wake of that issuance of the tornado warnings due to confusion resulting from those tornado warnings. It's called the Extreme Wind Warning, and temporally it's for a very short duration of time. It has to be when winds of 100 knots, so 115 miles an hour, are expected to overspread accounting warning areas, or WFOs, CWA within an hour. So it's much like a tornado warning, only a different name for the product. So, whoops, here we go. So going above and beyond, Katrina was an incredible event, and just a hurricane warning. Average template of warnings would not do enough for this. It was an incredible event. A Category 4 storm storm Category 3 upon landfall. So that's why Robert Ricks of the National Weather Service in New Orleans, Louisiana, issued this public information statement 21 hours before landfall. And you can see that this statement goes above and beyond. This is not your traditional inland hurricane warning. This is a real bona fide warning, and copy and pasted directly from the site. And you can see it's the most powerful storm with unprecedented strength, rivaling that of Hurricane Neil in 1969. They used so many different key phrases, and he said this was based off of a templated statement created by the National Weather Service, I think in Melbourne, Florida, in the wake of Hurricane Charlie. And he was going through debating whether or not he should delete anything from the text, and ultimately he decided to keep everything, just because he figured Katrina would be such an astounding event. And take a look at this. I just want to highlight some of the key phrases. The majority of all industrial buildings will become non-functional. Partial to complete wall and roof failure is expected. High-rise office and apartment buildings will sway dangerously, a few to the point of total collapse. All windows will blow out, airborne debris will be widespread, and may include heavy items such as household appliances and even light vehicles. Power outages will last for weeks, as most power poles will be down and transformers destroyed. Water shortages will make human suffering incredible by modern standards. So you can see just how heavily worded this statement is. And he says that he felt that the warnings issued by that office were extremely effective because the fact that they were in 21 hours in advance probably attributed to thousands of lives saved, just because most people who had been there, survived Camille, survived numerous other lesser storms, resisted evacuation orders until that heavily worded statement was issued. So, using hurricanes as a segue, we go back to Hurricane Sandy. And we know Hurricane Sandy was an epic fail in terms of warnings. I don't mean to offend anybody here, but this was a note issued by the National Weather Service several days in advance. They said, first, a note on the National Weather Service warning strategy for Sandy. Strategy making it sound like a game. In order to avoid the risk of a highly disruptive change from tropical to non-tropical warnings when Sandy becomes post-tropical, the wind hazard north of the tropical storm warning area will be conveyed through high wind watches and warnings issued by local National Weather Service offices. This I found in kicker because, take a look at this one, ready? Whether Sandy is officially tropical or post-tropical, a landfall will have little bearing on the impacts. So if there's no change in the impacts, why are we changing the products? Because a high wind warning and a hurricane warning convey two completely different ideas, despite the fact that even the National Weather Service admitted that we had the same impacts. So unfortunately, we can't have Chris Christie issuing every warning as much as it would be nice. I just need to turn the volume up. Is there a way to turn it up? Yeah. We'll see if it works. But you guys can hear a little of that. I'll resume the presentation in just a second. I want to turn this up. Whoops.
Hold down the function key and hit the volume up button.
Function?
There you go.
There we go. Oh, now I have to skip through everything again. I'm sorry about that. We'll go quick. Look at all the progress we're making.
Yeah.
Intermission music.
Yeah, intermission music. Thank you. You can get your coffee now. Yeah, we're just about there. I should have thought about this ahead of time.
I think you're crushing it, by the way.
Thank you. All right, here we go. So we can't have Chris Christie issuing everything.
Get the hell off the beach in Asbury Park and get out. You're done. It's 4:30. You've maximized your tan. Get off the beach. It looks like it's stupid to do. It is stupid. And, you know, I think all of our mothers taught us, if we could avoid it, don't be stupid. So don't be stupid. Get out. I turned out to be right. You turned out to be dead. That's not a great equation.
So, just like Mayor Bloomberg of New York, I hear, is now trying to apply to teach Spanish at local colleges, he's applying to the National Weather Service to issue new warnings. But the National Weather Service did issue a heavily worded statement. They were very limited in the fact that they couldn't issue hurricane watches or warnings. So instead they issued, similar to Robert Ricks of New Orleans, they issued a really heavily worded statement. They said if you're being asked to evaluate coastal location by state or local officials, please do so. And if you're reluctant to evacuate, and you know someone who wrote out the 62 storm on the Barrier Islands, talk to them and ask if they do it again. Here's a really scary one though. Ready? And sometimes it can't be politically correct in the warnings. They have to be very dead on. If you are reluctant, think about your loved ones, think about the emergency responders who will be unable to reach you when you make the panicked phone call to be rescued. Think about the rescue or recovery teams who will rescue you if you're injured or recover your remains if you don't survive. So extremely heavily worded right there. I'll skip these next two just for the sake of time, but you can see sometimes they have to break the rules. And we see the warning failures normally are due to certain things like the technicalities as we saw earlier. Audience not reached. Sometimes can't reach the audience or it's too scientific. I've seen warnings before that included the word convective fine line. Product overload, we saw that earlier out of the National Weather Service in Medford, Oregon. 7 different products saying the same exact thing, hazard seas warning, small craft advisory. I could go on. And the name of the product, are we warning on the name or the impact? Because earlier we saw from that pre-hurricane statement issued by the National Weather Service that whether or not Sandy was tropical or post-tropical would have little bearing on the impacts. So are we focusing on the impact or the name of the event, the product? So I think that's the big question we have to keep in mind. That's the impact-based warning study. And I love the impact-based warning survey program because it really gives truth to the impacts rather than just the technicalities and the name of it. I saw a severe thunderstorm warning the other day for 90-mile-an-hour winds, and they just copied and pasted the text from the tornado warning because 90 miles an hour winds sustained, and a weak tornado will have the same impact, so they just went with the impact and told people in both cases to get to the basement. So if the event was like a hurricane, the impact was the same as a hurricane, why didn't we warn for a hurricane? So this next part, I got to issue a disclaimer. I'm about to talk about the Joplin storm and kind of critique the National Weather Service's warning style. I delivered this presentation in Vermont at the Northeast Storms Conference, and I presented the material in a way that a few National Weather Service personnel took offense to. And I actually had an angry mob starting to form of like 2 or 3 National Weather Service people. So please know I respect the National Weather Service with the utmost respect above almost any other meteorological organization. And I'm not trying to critique them, I'm not trying to belittle them or bully them, I'm just trying to offer some food for thought. Yeah, angry Mets right there. So with the Joplin storm, we saw 161 people killed, and obviously something there didn't go well. But when we took a look at the warnings and why it was unsuccessful, which I'll get to in just a second, we noticed numerous different things. For example, the motion of the storm was reported incorrectly by the warning generation program, as was the location. Everything needed to be manipulated by humans more. And admittedly, it's not the traditional supercell, but you can see the debris ball right there. You can see the gentle curve of the storm. So even though it's not the supercell, people should have been able to see that clearly this thing's motion is not changing. It's moving due east from Helena into the city of Joplin. Pretty consistent track, pretty consistent speed, everything like that. So why do we see the speed changing so much in text issued by the National Weather Service, as well as the location of it was all over it. In fact, I connected the dots of the locations reported. I'll show you that earlier. And I was like someone was trying to draw, I don't even know. With that, there were numerous factors working against the people at Joplin that day. There was an incredible latency of the data, on average 4 to 5 minutes before a warning reached the public. The warnings kept emphasizing Galena and Carl Junction. In fact, the tornado barely hit Galena, completely missed Carl Junction, and it completely neglected the fact that there was a massive tornado heading towards the city with 60,000 people. And like I said, the motion of the storm was reported incorrectly, and the location of the storm incorrectly. And like I said earlier, product overload, when we have too many tornado warnings or too many severe thunderstorm warnings coming at once, that can cause confusion, which we saw. Because 8 minutes earlier, northern Jasper County, Joplin's in the southern part of Jasper County, northern Jasper County had been placed under a tornado warning. So there were a lot of different cells going on, a lot of different aspects contributing to that confusion. Here we are. So 5:09 p.m., this was the original issuance of that tornado warning. And we saw it's moving east at 30 miles an hour, 6 miles east of Columbus, 30 miles an hour. And the warning didn't even include the city of Joplin, it just said northeastern Joplin, as you can see right there. And I want you to keep in mind the motion and direction of the storm, as well as texts issued through the bulletins, how it should have moved. So by 5:17 p.m., and you can see the statement says 5:14 p.m., showing you the latency of the data. Northeastern Joplin is no longer mentioned, they issued Joplin. But I'll show you the radar image at this point. It's starting to be evident that there's going to be a tornado in the vicinity of Joplin. And you can see that gentle hook starting to form. It's not very prominent at this point, but it is clear that there will be some sort of tornadic storm entering the city of Joplin. And I think when you have a city that large in the path of a tornadic storm, you give more than maybe one word just in a random list of a bunch of different towns. Now 5:24 p.m. was when it really became evident this storm was going to hit the city of Joplin. Its location was near Galena, and we saw that's a little bit due west of Joplin. And if it's moving due east at 20 miles an hour, common sense dictates it should enter the city of Joplin. And you can see that hook echo right there, and the base velocity is showing very prominently a circulation. For whatever reason, I can't find good graphics. I can only get the red and the green. You guys all have those cool velocity images. So unfortunately, I can't show you the cool velocity images with the red and the yellow and the blue. I'd like to, but we're going to have to stick with red and green for now. But obviously, you can see there's going to be a major circulation heading towards the city of Joplin. But yet again, Joplin is only mentioned in a very roundabout manner, like a regular tornado warning. And it's suddenly slowed down there to 20 miles an hour. By 5:39 p.m., somehow it's still near Galena, even though 15 minutes has elapsed. And the circulation is well past Galena, heading towards the city of Joplin itself. And this is a point when you can really see that prominent hook echo. And Joplin at this point is still just giving out random word. I would think that at this point, with this massive circulation, with winds probably, I think gauge to gate at this point was around 130 miles an hour. With winds this strong, with a hook echo this prominent, even a flanking line in inflow, you would think more than just one word would be issued, showing you how sometimes regular warnings just aren't enough. And by 5:48 p.m., 5:41 was when the tornado actually hit the city of Joplin. 5:48 was when everyone went, oh, and said, yeah, there's a damaging multi-vortex tornado. By the way, how many members of the general public know what a multi-vortex tornado is? And somehow, even though it's past the city of Joplin, Joplin is still mentioned. And you can see right here the debris ball very prominently, and there's that circulation path in the city of Joplin. I'll try to pass these next two because it gets fairly repetitive. You can see there's still nothing really clarifying the fact this is a massive tornado, just caused numerous fatalities, huge tornado, massive damage. It just says trade weather spotters reported tornado producing damage. That can mean anything. So we're going to plot the location and direction, and you can see it's going east. Then suddenly it bounces to northeast according to the National Weather Service. It goes from 30 up to 40, to 20, and speeds up to 45 miles an hour. Much like the people on Route 3 South, if you've ever driven on the Cape and the Islands. So we show you, we're going to plot all these. And I did two different things. I plotted them on a map. And the first time, I just connected the dots, and you'll see that right here. All the blue dots are basically just the locations reported by the National Weather Service. And I connected those trying to find the path that this storm took. But then the second time I did something a little bit different. I took the motion reported and a time interval between the two different statements. And I assumed, let's say the first statement said it's moving at 15 miles an hour northeast. I assumed that the whole time between that and the next statement, the next update provided, it was continuing that same vector for the whole time. And that's how I got the second path, given by the motion and direction of the storm as well as the speed. And you can see that's nowhere near the city of Joplin. And that's why Galena was focused on and emphasized the whole time. So I'll plot that, and I'm going to put on the original track of only connecting the dots, and we'll compare that to the actual path that the tornado took. And you can see, here's the path the tornado took south of the city of Joplin. Didn't even hit northeastern Joplin, and northeastern Joplin was emphasized the entire time. And the only time these tracks actually coincide, very, very briefly, along that time when the tornado turned to the right and turned to the south towards the end of its life cycle. So you can see, sometimes relying on the computer to include the motion, the direction, and all those other attributes of the storms is counterproductive and really cuts into the effectiveness of a warning. And my question was, why wasn't a tornado emergency even considered? And the tornado emergency now has become even a cookie-cutter type warning, because from the National Weather Service in Des Moines, it has to be once in a 10-year event. How you gauge that, I don't know. And it has to be multiple fatalities, a large population, and visually confirmed. The fact that it has to be visually concerned really bothers me, because I don't believe the Joplin tornado was visually confirmed for quite some time, because it was rain-wrapped and difficult to see. What if you have a huge rain-wrapped tornado? That's going to prevent it from being visually confirmed. The National Weather Service in Nashville says it has to be through a highly populated area. Well, would the El Reno tornado not have received a tornado emergency? I think it was 2.6 miles in diameter, or 2.7 miles in diameter. Massive tornado, incredible damage, 300-mile-an-hour winds. But because it's not going through a populated area, does that mean that people who are in an unpopulated area, who live in the country, are less deserving of receiving accurate statements and safety than other people? I don't know. There has to be a debris signature evident in radar, which I kind of agree with. And it's not to be used before the third statement, the third severe weather statement issued by the National Weather Service. We saw that with the Moore tornado, that tornado emergency was issued at 3:01 p.m., the exact time that the original tornado the tornado warning was issued. And we saw that because it was included in the first warning, people tended to listen to only the first warning, and that just shows how effective it was. So I don't understand why it has to be used after the third severe weather statement. And by the way, for anyone who's interested, Mike Smith has a great book out. It's called When the Sirens Were Silent, and it's a great case study of the Joplin tornado. So let's take a look at how other countries do it, because we know that our system obviously is not quite flawless, but how do other countries do it and does it work? Well, Canada, for example, and I think Canada does it the best out of anybody, they say there's a tornado warning for X, Y, and Z, and they end the tornado warning for whatever places the storm has moved past. And I think this is interesting because they don't really include all that safety information. When you guys got here, how many traveled via airplane? Yeah, a lot of you. And how many on that plane heard that safety spiel about how the oxygen mask is going to drop from the plane, all those horrible, scary things? You guys know what's going to happen. We don't need to listen to the same speech every single time. And I think that including that same safety information, well, sometimes in areas where severe weather doesn't commonly strike, could be helpful. I believe that in areas where severe weather is really frequency area, could be counterproductive. And that's why, rather than cluttering the warning with all that safety information, Canada just says start time, end time, and includes a discussion. So every single case is unique in the eyes of Canada. Exactly, we need to model our warnings more after. Japan does a lot like we do. We have tons of different warnings. They don't issue severe warnings, which I find interesting, for convection. They only issue advisories, basically like a watch saying convection is possible in this general area, and each one contains a narrative. So each one is very case-specific, unlike ours, which is just a templated cookie-cutter warning, where the only thing that might be unique is a single motion, vector, things like that. And they have 3 different cases where they issue the emergency bulletin. I won't go into that too far. And the Met Office in the UK does something very similar, and I think this is great. Dan Satterfield was talking about this earlier, where they have 3 different levels: be prepared, be aware, and take action. And they issue those for whatever the event. The event doesn't matter to them, only the impacts of the event and how that event will be rendered in terms of impacts dictates what color will be issued in just 3 different levels of warning. Basically advisory, watch, or warning, which I think is the most effective way to go. Australia does it much like we do, which I don't necessarily agree with. Very technical, not to the general public. So again, there are many different ways we can do it. So what are the solutions to this very templated cookie-cutter warning style that we use? Well, for example, I think every single warning should be unique. And I've heard criticism before that could cut into a warning lead time. Well, then issue the original tornado warning, severe thunderstorm warning, and then follow it up with more detailed information or more case-specific information and follow up severe weather statements. You need to ignore the technicalities. Sometimes they have to break the rules. If it's marginal, if it's borderline between issuing a winter weather advisory and a winter storm warning, go for the warning sometimes. Consider the impacts. And I think that's interesting because Atlanta, for example, 2 inches of snow will mean something completely different than in Boston. Now, technically, the criteria for a winter storm warning is 6 inches in a 12-hour period. Atlanta didn't have that, but they issued the warning anyway because of the impacts, which I think is good. Occasionally, admitting to low confidence, I think, is sometimes important because, as we saw with Joplin, they may not have known exactly where the tornado was going, even though it was fairly prominent on radar towards the second half of the storm's life cycle. But if they just said, okay, the tornado is possible in any of these areas, it's possible that it's a strong tornado, damaging tornado, I think people would have reacted completely differently than them just locking onto one track and saying, it's going northeast, it's going to hit X, Y, and Z, because that leaves other people completely out of the loop. And manually editing the motion and direction of storms, we saw vitally important in the Joplin event, because the motion and direction of the storms were reported incorrectly. So with that, I invite you to ask any questions. Hopefully you guys have some interesting comments you wanted to make. Anything?
I think that, just so you know, coffee, please go. But for those of you who want to stay, we'll continue the conversation through this. And maybe just come on up here and do it more intimately with Matt. So thank you. Great job.